In my previous video, we discussed about basic introduction of gravitation and gravitational force. Further, we also discussed the concept of object falling downwards, that is towards the center of the earth. If you haven't seen that video, I request you to get back to that video and just see it once. In this video, we are going to talk about Newton's law of gravitation. Newton's law of gravitation. Okay, so consider an object, one of the object lying here, and mass of object is m1. Now there is another object lying over here, and the mass of this object is m2, and the distance that separates them is r, that is capital R. Now mass m1 is in kg, so this is m1 kg, this is m2 kg, and this is r meter. Units are important whenever we study physics. Okay, now as I just taught you in my previous video, that any two objects that exist in this universe would attract each other by some gravitational force. Newton's law of gravitation gives us the idea or a clear numerical figure about the magnitude of the gravitational force acting between them. So let us understand it. Suppose we denote the gravitational force existing between two objects m1 and m2 by capital F. So F is the gravitational force existing between m1 and m2. Let me write it down over here. F1 is equal to gravitational force acting between masses m1 and m2. Okay, then this is proportionality sign. Then according to Newton's law, F is proportional to product of the masses. F is proportional to the product of the masses. It is directly proportional to the product of the masses. And F is inversely proportional to the square of distance between the masses. So what it means that F varies directly as the product of masses, means if any of the two masses increases, the product shall increase, and as the product increases, this force shall also increase. And F is inversely proportional to the square of distance between them. So as the distance increases, force F, that is gravitational force, would decrease. Now we can combine these two equations like F is proportional to m1 into m2 upon r square. Now we need to remove this proportionality sign and replace it with some equal to sign. So F is equal to m1 into m2 upon r square. Now we need to add some constant over here. We need to add some constant. That constant is k. Now that constant k, in case of gravitation, is replaced with g. This g is called gravitational constant. This g is called gravitational constant or universal. G is a universal gravitational constant. So G is a universal gravitational constant. So basically F is equal to G into m1 m2 upon r square. This is a mathematical form of Newton's law of gravitation. So let us have the statement of Newton's law of gravitation. How will we define the Newton's law of gravitation? According to the Newton's law of gravitation, every object attracts every another object by the force which is directly proportional to the product of their masses, which is directly proportional to the product of their masses, and inversely proportional to the square of distance between them. So this is called Newton's law of gravitation, which says that all the objects in the universe keeps on attracting each other. Note that force of gravitation is always attractive in nature. It is never repulsive. Further, mass. Mass is the main source or cause of the force of gravitation. Just like charges give the electric charge give rise to electrical force, mass gives rise to the gravitational force. Okay, now this is the gravitational constant G that we just introduced. Let us understand a bit about that now. G. So, what is G? It is, as I just said, it's a universal gravitational constant. But just in case we want to define it, we can define it like this: F is equal to G into 1 kg of mass into 1 kg of mass upon 1 meter of distance. So we are assuming that there are two objects, both of mass 1 kg and separated by the distance of 1 meter. This is 1 kg and this is 1 kg. Then what will we get? F is equal to G. So what is gravitational universal gravitational constant? It is the force of gravitation that acts between two objects of mass 1 kg, each of mass 1 kg and separated by a distance of 1 meter. Let me write over here is G, that is universal gravitational constant, is the force of gravitation acting between two objects, each of mass 1 kg and placed at a distance of 1 meter from each other. Okay, so this is how we define it, and the value of G is 6.67 into 10 raised to minus 11, and we need some unit over here. Okay, each and every quantity in case of physics would have some unit. So how will we derive the unit for G? Okay, I have some less space, so I will have to just make some arrangement for the space right here. Okay, this would do. Let me just change the color. Okay, G. The unit of force F is Newton. We are simply replacing each and every quantity with its unit in this equation, except G, because we want the unit for G. We will keep G as it is. Unit of this mass would be kg, another mass would be kg, and distance square would be meter square. So what would be unit of G? Unit of G would be meter square Newton per kg square. So it's basically Newton meter square kg raised to minus 2. This is the unit of G. So let us have some brief recap of the entire session. So today we started with the Newton's law of gravitation, which is the governing law for the gravitation. If there are two objects separated by some distance r and mass of each object, mass of one of the object is m1 and the mass of another object is m2, then the force acting between them would be directly proportional to product of their masses and inversely proportional to the square of distance between them. And then we introduced one constant called universal gravitational constant G, so that F is equal to G into m1 into m2 upon r square. Now, uh, so this was the mathematical representation of the gravitation law. In the form of statement, we can say that according to Newton's law of gravitation, the force acting between two masses is directly proportional to the product of their masses and inversely proportional to the square of distance between them. This is the statement for the Newton's law of gravitation. If I am going a bit fast, uh, I'm sorry, but I think you know it, right? And yes, this is the important concept. Mass is the main source of gravitation. So if you have a question on the paper that what is the reason behind the force of gravitation, what was the reason for existence of the force of gravitation, then the answer would be the mass of the object, because mass is something that creates the force of attraction, gravitational force. Okay, and then we derived the unit for the G, and its value is 6.67 into 10 raised to minus 11. So this was all that we covered in this session, and in next video we are going to talk about why force acting between the objects on the earth becomes insignificant. We are going to have some mathematical analysis about that. It's really simple and interesting. Okay, thank you.